Hey guys, my name is Pearl, and today we're going to be solving this question 2.19 from the Engineering Mechanics textbook. I will solve 2.20 in the next video. So it says to determine the magnitude and direction of the resultant force F bar by adding F1, F2, and F3 of the three forces. So, they want us to do it in a specific order. First, we resolve F1 and F2, which equals to F bar. Then we add F bar to F3 to get the final resultant force. So the first thing we're gonna work with is we're first going to draw our resultant force. This is kind of like more like a rough guess. So the resultant force for F1 and F2 should be somewhere about here. And its direction, because of course has a direction, with theta bar. Now to draw the parallelogram, so we're going to drop this and drop it down to here. Now I want to draw this out so we can really get a clear view of what I'm working with here. And this is going to be for F1, which is 13 newtons. This is going to be for F2, which is 20 newtons. So we're going to draw the parallelogram. This is going to be the F bar. I'm going to draw a kind of imaginary horizontal line here. And this is going to contain our theta bar. Now, there's some angles we already know. You know from the picture that here is 20 degrees. You can see at this point, 20 degrees. So that means from this horizontal line to this point will be 70 degrees because this is 90 degrees. 90 minus 20, 70 degrees. So now, there's some certain angles we like to get. Let me bring out to the triangle we're going to be working with. I would like to work with the top triangle, which here's 30 newtons. This is the dashed line. This is F bar. This is, yes. Now this angle, we do not know it. And this angle, we do not know it either. This angle will not be particularly important to us. So now to find what this angle is, I'm going to do something like you may not really understand it per se, but I'm going to explain it well. We know we can find the angle from here to here. The reason why, remember they gave us this small triangle stuff here, very cute. 3, 4, and 5. With this, let's call this angle phi. With this, we're actually able to find, this is for the first F1, we're actually able to find first F1's direction. Phi will be equal to tan inverse of the y component of F1, that's 3, and the x component of F1, that's 4. What we get is 36.87 degrees. So we're just gonna write it here. 36.87 degrees. Now since we know the angle from this point to this point, we know the angle from this point to this point. We can simply say that the entirety of the angle here is 70 plus 36.7, which is 106.87 degrees. Now in a parallelogram, angles that are adjacent to each other, that is this angle 106.87 and this angle here must add up to 180. So in order to get the angle at this point, we're simply going to do 180 minus 106.87. That's going to give us 73.13 degrees. So 73.13 degrees, which means we've gotten what we need here. Now the angle at this point, you see we're having alternate angles. You can see this makes like a kind of Z shape at this point. These are two parallel lines crossed with a transverse line. So this point is going to be 70 degrees, which means from here to here is going to be 70 degrees plus theta. F bar, we're going to use the cosine rule. Is equal to the square of both sides. The side is going to be 20 newtons because it is parallel. You can say this point it is parallel to this point. So here is going to be 20 newtons. 20 Newton square plus 30 Newton square minus 2 times 20 times 30 cos the angle directly opposite F bar 73.13. That's why I wanted to find the angle. So F bar is going to be equals to 30.85 newtons. Now to find theta bar, I'm going to use the sine rule. We simply have 30.85, which is now F bar, over the sine of our known angle 70.13 degrees equals to 30 over sine 70 plus theta bar. Now to just simplify things for ourselves, I'm going to make this alpha. I'm just simply going to equate this to alpha. If you make alpha subject formula, you're going to get that alpha is equals to 68.52. Now remember that alpha is equals to 70 plus theta bar, which means if you make theta bar subject formula, is equals to alpha minus 70. So this in calculator, you're going to get minus 1.48. Now you may be thinking, why is it negative? It just simply means that the F bar is rotating from the positive x-axis in the clockwise direction. That's just all it means, just telling you direction. Now we're going to move on to adding F bar to F3. Now going back to the question, so F bar will still be there. Now we're simply going to resolve F bar with F3. I'm going to draw out the parallelogram for it. I'm going to draw dashed lines in this direction and then join it. So this is the parallelogram. I'm simply going to draw it out to avoid confusion. This is the line for F3. This is our F bar, sorry. This will be the resultant force somewhere in the middle. You can simply connect the dots with a parallelogram. Now the angle for FR, sorry, this is badly written. For FR, we'll start from the horizontal to where the resultant force is. This will be the direction for the resultant force. Now the certain angles we should know. Remember that we found what the angle was here. Remember the angle here was theta bar, and we found theta bar. Theta bar was 1.47. So I'm simply going to write that here. 1.47 degrees. By means of alternate angle, here's also going to be 1.47. Now I'm going to bring out this particular triangle. This is going to be, where do I draw it? At this point. Okay. Okay, so this is going to be FR. This is going to be F bar. This is the angle we know. Yes. So, and this is F3, by the way. Now to get FR, we can simply use the cosine rule again, which is going to be F bar square plus F3 square. We actually know these values. I don't know why I keep writing them abstractly. This was 30.85. That's for F1 square plus 50 square minus 2 times 30.85 times 50, cos we got the angle here 1.47 degrees. You solve this in your calculator and you're going to get 19.2 newtons. Now to simply get theta, we're going to use sine rule. We have that an alternate angle. Just want to include theta in the angle. This is an alternate angle, so here's also theta. So we can simply put theta here. Then using the sine rule, we can say FR, which is now 19.2 Newton, over sine of 147, because they're directly opposite each other, is equals to F bar. F bar is 30.85 newtons over sine of this unknown angle theta. Make the subject formula, including to your calculator, going to get 2.37 degrees. So therefore, this is the final answer. Thank you. I hope you understood. If there's anything you did not understand or was unclear, please do not hesitate to ask it in the comment section. Thank you for listening and